All right, so there we go. So, all right, so I just took a screenshot, and there's the same question. I'm on the program that's recording now. So, all right, so what do they want? Well, they say use interval notation. You guys know what interval notation is? That's where you do brackets, and you do left edge, comma, right edge of the piece of shading. So here's the left edge, here's the right edge, huh? So what is that, 4 and 9? That's pretty simple. Oops, it's not working too well. There we go. 4 and 9. That's it. That's all they want in that question. Do you guys know the difference between when you use brackets versus parentheses? Do you remember that kind of thing?
Wouldn't that be like a graph, like a bigger graph would be like the parentheses, like X and Y?
Yeah, well, yeah, they can do that. Yeah, and in fact, actually, on this one, it's just straight ahead, huh? Because they have brackets on the very graph. So I guess, yeah. Let me hold off on talking about that until we have an example. Yeah, this one clearly, they have brackets, so I use brackets. If they had a parenthesis, I would use a parenthesis. Well, let me hold off on what that means. So let's move on. So I'm going to flash away from that. You may or may not have got that all. That's the whole answer. That's all they want on that one. I'm going to flash away. Okay, so here's question number 2. The difference on this one, you can't really see, it goes off screen a little bit. There's an arrow over here. It's still barely off screen. So there's an arrow, which means that shading goes forever to the right. There's not a bracket over there, in other words. There's an arrow, so it indicates that the shading goes forever to the right rather than being stopped with a bracket. So what does that mean? Well, it just means that it's left edge, right edge. And so the left edge is, well, what is that left edge? Can you tell? Yeah, it looks like -1, huh? And what is the right edge then? Yeah, it's just infinity, huh? By the way, if the shading goes left forever, that's negative infinity, huh? Left forever is negative infinity, right forever is positive infinity. So infinity. Now, do I put a parenthesis or a bracket next to infinity? Yeah, always parenthesis. You're right. Yeah, because you can never be right on infinity. Always parenthesis next to, oops, come on, infinity. That's because, so what the parenthesis means, whoops, I'm trying to erase stuff and it's not working. Parenthesis means, come on, pen, means close but not right on. Close but not right on, whereas brackets mean right on the number. Straight. Brackets have a straight edge, so like you're straight on that number. So when I say bracket -1, that means I'm right on the money, right on -1. If I put a parenthesis -1 to infinity, what that would mean, that's not a very good parenthesis. It looks like a bracket, kind of. So let me try that again. So if I put a parenthesis, that would mean close to -1, like -0.99999, but not right on -1. Just, it's rounded. It's like being close to it, but not right on. So in general, that's what parentheses mean. Parentheses means you're close to the number, but not right on. Bracket with that straight edge means straight on that number. So that's why then it makes sense that infinities never get a bracket, because you can never be right on infinity, huh? You might go to the doctor's office and say, I waited forever. But you didn't really get right on forever. It just felt like forever. So that's why they always get, infinities always get a parenthesis. You're never right on them. All right, let's keep going. All right, so number 5 here. So can you all read that okay? It says 0 less than or equal to x less than 5. And they want me to turn it into like an interval kind of notation, left edge, comma, right edge sort of thing. And so it's clearly going to be 0 and 5, that's the left and the right. But will the 0 get a bracket or a parenthesis?
Bracket.
Yeah.
Because of the equals bar, we're going to have a bracket because of that bar, and a parenthesis here because that has not less than or equal to. It's not right on the 5, is it? It's not right on 5. Pen's kind of slow. We all good with that? So parentheses when you're not right on the money, not right on the number.
0 gets a bracket because it's before the.
Yeah, 0 gets a bracket because it's greater than or equal to 0. It can be right on 0, can't it? It can be equal to 0. But it can't be equal to 5. It's got to be less than 5. It could be 4.99999, less than 5, but not equal to 5. Huh? So parenthesis, it's close to 5, but not right on the 5 on that. Okay, so number 8. So they're giving me bracket 7, 9, like that. And they want me to turn it into some kind of an X statement. So now we're going the other way, right? We had the X statements, make them interval. Now it's interval, make it into an X statement. So how am I going to write that? How do you do the X thing? Anybody know already off the top of their head? How do you write that? Is it like X greater than 7 or less than 9? Or what do I do?
It's 7 is greater than or equal to.
Like that?
The other way.
Okay. Makes sense how what you said was greater, so but you mean less than?
Yeah.
Mm-hmm.
X.
Uh-huh.
And then
Yeah, which way?
X is the thing's gonna be eating the 9.
Yeah. All right, we'll go with that. You're totally right.
Yeah.
Yeah, exactly. Exactly. Is everybody okay with that? Is that right? That is exactly correct. Let me erase the other goofy thing I wrote. Yeah, let me help with that. Let me help you see that that's logically true. It's because did some kind of funny thing. Anyway, it's because this is like small. It's like ordering a soda or something. Small, medium, and large. Come on. Small, medium, and large. In other words, 7 to 9 means all. If you do the number line, might help. You don't have to number line, but it might help the concept. It's all the numbers from 7 to 9, right? The X is the shading. The X is all the numbers from 7 to 9, which means X is between 7 and 9, right? Why do the symbols both go this way? Well, because a small is smaller than a medium, and a medium is smaller than a large, right? This is the small number, this is the large number, X is between them. So it's the medium. So the smaller is smaller than X, and the X is smaller than the large. It's between. That's what it means to be between, to be medium, right? So both less than. Symbols are both less than, but that's logically correct. Does that make sense? Am I good on that? Okay. All right, so, whoops. Seem to have. It's giving me some little message here. So multitasking gestures interfere with both the group. General settings menu and turn off multitasking gestures. All right, whatever. Here we go. Here's the problem. Can you guys see it okay? Oh, yeah, it's on the screen. Good for you guys. Okay. Yeah, let's solve that thing. So go ahead, if you have not, go ahead and start doing the steps necessary to solve that thing. So you start by distributing, right? At -2, boom, and a boom. Get negative 6x plus 4. We get to there? And now how do we solve for x? You guys know, right? Subtract the 4. Okay, and then, and what's the last step? Divide by the -6, right? So divide by the -6. Okay. And what?
Flip the sign.
Good. I'm making sure you know that. Do you remember that from your algebra days? That when you divide by a negative number, that symbol needs to flip the other way. So let me write a note on that. So this symbol right here needs to turn the other way, and then this is -1. So yeah, so when we divide by a negative number, flip the symbol. Oops. So I flipped, because I divided by a negative number, I had to flip the symbol. So that's what testing that you remember that. Good on that one? Does that make sense? Remember all that from your algebra? So it's really a review of algebra, but all right, so there we go. So 1/6 parentheses x minus 15 greater than x plus 20. So guys, let me suggest that you first get rid of that 1/6. Don't distribute. I mean, you could. It's not illegal or anything. But it'll be quite a bit easier for you to first get rid of that 6. So whenever you have fractions, my general advice is going to be just to get those fractions out of there on the first step. It's just life is so much easier when there's not fractions around. So that's what I would, even though it's okay to distribute, you know, you could distribute, it's easier just to get rid of it. So what I'm saying is I would multiply by 6. And that's all you need on the left side. Whereas on the right side, you need a 6 for each of them. Now why? Why do I just put 1/6 on the left side? It's a good question I often get. Students will say, why are you doing that? It's a really good question. It's because I really have done the whole left side by just doing the front, right? Because whenever you do something, whenever there's parentheses, see how the left side has parentheses? Whenever you got parentheses, anything you do to the front of those parentheses will eventually distribute through to everybody, won't it? So you really have done it to everybody on the left side by just doing it to the front of the parentheses. So I really have done the whole left side, all the terms on the left side, and of course I did both the terms on the right side. So that is equal treatment, which is always what we're doing in math, right? Treat the two sides the same, and whatever was true of them before will still be true. So what happens is these cancel right away. That's why we did it. Wanted rid of those, right? And then we have x. We don't need the parentheses anymore. There's nothing to distribute. And this is 6x plus 120. We good to there so far? So much nicer now, right? No more fractions. See how the 6's canceled instead of multiplying? That's what we wanted. Wanted it out of there. Okay, so now what do we do? Do you know the next step? You got to do something about those. Don't worry about the 15 and the 120. First, do something about the x and the 6x. You don't want two x's in there. You want to get rid of one of those, right? So you can get rid of either one. It doesn't. You can subtract 6x from both sides or just x. I usually just get rid of the lower one, but it doesn't matter. You can do whichever way you prefer. Usually I just get the lower one out of there. But you could do minus 6x in both cases. That would work too. And then these are gone, and it's minus 15. This is 5x plus 120. Like so. Now it's more normal, right? Just subtract the 120. Now you just work to get x alone. Minus 120 from both sides. What is that? Minus 135. You can use calculators on everything. These are gone. 5x there. Last step is always divide, right? So divide by 5. What is that? Negative 27? Okay, thanks. Negative 27. Now that's a true answer. That's the right answer. I'm fine with that on a test. But notice the Math Excel has put all the x's on the left. So we got to figure out which one of these. We have x on the right, they have x on the left. Which one of those is the same as our answer? Well, you know, when you flip it, you flip the whole thing, symbol and all, don't you? Not because I'm dividing by a negative. So don't confuse that with when you divide by a negative, you have to flip just the symbol in the middle. That's a different animal, right? Right now I'm saying, well, I want to flip the entire expression. so that it says the same truth, but it says it with x coming first. That's the same truth, isn't it? X is on the narrow side, which means x is less. X is on the narrow side here as well. See, those are saying the same thing. They're both saying x is less. X is less. Remember, those statements can be read left to right or right to left. It doesn't really matter. They say the same truth either way, don't they? Either way you want to read it. Negative 27 is on the wide side, so negative 27 is greater than x, or x is smaller than negative 27. That's the same thing. As I say, John is older than Mary, or Mary is younger than John. It's the same truth. Either way you say it, right? Yeah.
How come the answer choices have like X on X?
Oh yeah, that's just it's called set builder notation. You don't have to worry about that. I'm not going to expect you to know that. Yeah, when they do this, if you really want to know, it means it stands for some words. It means the set of all. It's shorthand notation for the phrase the set of all x. That's that first x. And then you know what that straight line means? Anybody know? Math lingo? It's shorthand. It means such that. Math people say such that so much. If you go higher in math, you prove things and you do that line because you don't want to write the word such that. It means such that. So anyway, I'm not going to quiz you on all that. That's all that means. The set of all x such that, and then comes this. Well, yeah. So just look for this right there, which is, no, it's not right there, is it? Where is it? D, I guess it's D, yeah. So don't worry about that other stuff. Just look for that and you'll be good. Good on that? Questions? All right, so number 17. All right, so negative 5 is less than 4x minus 6 over 5 less than, come on, less than 0. All right. Yeah, we're a longer class. We go to so if you want to bring food, I'm fine with that, even though it says no food. This will, and if you need to run to the bathroom or do that kind of, I'm fine with all that stuff, as long as it's not disruptive. So the only time you'll hear me complain is if there's so much coming and going, people are having trouble focusing on the math, or if it's like a really loud food and you're crunching on chips and people are having trouble paying attention, then I'll complain and ask you to think about those around you. Anyway, otherwise I'm fine with all that stuff. All right, so what are we going to do on this one? So it's a triple. It's got a left, middle, and right. So, but let's first do the fraction thing. Let me let you do that. Go ahead and do what you need to do to get rid of that 5, right? We don't want fractions. Always do them first. Whatever you do, you got to do it to all 3 parts: left, middle, and right. Middle and right. So you just multiply by 5, don't you? 5 there, 5 in the middle, 5 in the right. Why only one 5 in the middle? Well, because it's just one big fraction, huh? So these 5s cancel. Is that good? That was the whole purpose, wasn't it? To make there not be a fraction any longer. Like that. And so then what do we got? Negative 25. This will be 4x minus 6. 0 times 5 is 0. We get to there. Okay, so we got rid of the fractions. That's good. Now, focus, when you're solving these things, always focus on x, right? Always focus on x. It's all about x. X is saying I want to be alone. So that means you got to get rid of the minus 6, and you got to get rid of the 4. Do the minus 6 first. How do you do it? You do the opposite. It's always the opposite, huh? So, and whatever you do it to all 3. So we're going to add 6 to all 3. Like that. So what is that then? Minus 19? Yeah. 4x. And it's not working. 6 like that. Last step is divide by 4. And that's the answer, except we have to reduce that 6/4, don't we? Now, how do you know if they want fractions or decimals or what do they want? Well, look at the blue line. Type your answer in interval notation. Use integers or fractions. integers or fractions. In other words, not decimals. On this one anyway. Other times they'll say decimals, you know. Just watch the blue line. They'll always tell you what they want. So minus 19 fourths x. And then what do you do with 6 fourths? You've got to reduce that thing, right? Divide top and bottom by 2. 3/2, like that. Now, they say interval notation. That means they want the left edge, right edge kind of thing. Am I going to do parentheses or brackets on this one?
Parentheses.
Yeah, does everybody see it's parentheses because there's no equals bar? There's the answer they want. Right? If this had been equal to, less than or equal to, less than or equal, then I would have made those brackets, wouldn't I? Everybody see that difference? Because then it'd be straight on. When you're equal to something, you're right on it, and you have the straight back bracket, which means straight on the number. But they're not equal, so we're just close to those numbers. So there's the final answer they want. Is it getting warmer in here? They're turning on the heat here. I usually wait till test day for that. No, I'm kidding. I have no control over it. I don't know why it's so warm in here. All right, so we good? All right, so there. All right, yeah, let's do this. And this got a bunch of fractions. Basically, guys, multiply through by all those numbers multiplied together. So 3 times 4 is 12, times 5 is 60. So I'd go 60, 60, 60. Does that make sense, what I'm saying? You want the common denominator, which is all of those multiplied together, and you want to multiply it top, top, top to get rid of the fractions on the first step. So the LCD LCD is 3, bless you. 3 times 4 times 5, which is 60. LCD is 60, and then just multiply that 60 top, top, top. So I'm going to put 60, 60, 60, top, 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 like that. LCD, and then just cancel. 3 goes into 60, what's that, 20 times? 4 goes into 60, what, 15 times? 5 goes into 60, 12 times. And then the leftover, 20, 15, and 12, will multiply the leftover 1, x plus 1, and 4. You guys with me? Is that making sense? So 20 times 1 will be 20. And then the 15 will go boom, boom, and hit the x and the 1. 15x plus 15. And the 12 will hit the 4. 48. We good? So that's, I think the rest will be easy for you. But is everybody good through those first 2 steps? So I multiplied all 3 denominators together, got the LCD. And then top, top, top with the LCD. Remember all that from algebra? Some of the hardest stuff from algebra, right? On that. It's all these kind of things that I'm going to try to use our time to spend. I really want to spend time with you doing algebra because that's what you need for calculus. People who don't make it through calculus, really it's not the calculus, it's all the algebra. It's all the mess of the algebra that bogs them down. So really, I hope you're devoted. I'm devoted to trying to help you learn algebra as much as possible. Even though you think, well, I had algebra. Yeah, but I mean, really refine your algebra skills. That's what you need to make it through calculus. Because they'll have like pages of algebra, you know, and if you're messing up every second or third step, it just kills you in calculus because there's so much of it. So is that good? Remember all those LCD, denominator, fraction things? Questions? I'm glad to answer questions. That's a lot of what I want to do is really help you with all that. So you 60, 60, 60, cancel, 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 leftovers multiply. And now the rest we just, again, focus our attention on x, right? It's all about, you know, it's like there's 3 sections. X is saying, I want to be alone. Get rid of these 2 15s with me, right? So subtract 15 from all 3. Whatever you do to one part, you do to all 3. and you get 15, x in the middle, and then this is what, 5, and what's that, 33? And then last step is divide, right? Camera. So, these cancel. That's what, 1/3, reduce that there. And that one doesn't, but reduce it by 3, doesn't it? By 3, top and bottom. So whatever you can divide, you gotta do that. So 11/5. There we go. And they want interval. You can tell which one it is. 1/3 to 1 to 11/5. Oh, and I lost the bar here, didn't I? It was less than or equal to, and I suddenly lost that. It's supposed to be less than or equal to, less than or equal to. So that means we need the bracket on the 1/3, because it's got the equals, the left side. And the right side does not have the equals, so it's just the 11/5 with the parenthesis, which my pen will not do. There we go. So that's the answer, right? We good on that? Remember all that algebra? We'll do more and more of that. Questions I can answer? All right, I'll move on. So, yeah, let's talk about absolute value. All right. In the interest of time, let me say, if you have absolute value of something on the, well, let's just call it x. So I don't have to write so much. Let's just say x, absolute value of x, equals a number. That automatically means that x can be the positive, whatever that number is, or x can be the negative of whatever that number is. This column over here is going to have absolute values, and this is going to be absolute values removed. All right, is that making sense? So if you have absolute values equal a number, then that number can be positive or negative. I think an example, well, let me write out the 3 cases, and then I'll do examples, which will make more sense. Yeah, that's probably the best way to go. So next case, absolute value less than a number, or let's just go less than or equal to. What does that mean logically? Well, let me just give you the steps, and then I'll do examples that'll hopefully make more sense of it in a minute. That means the absolute value, remove the absolute values, and the x is between the negative and the positive number. And finally, third case, so there's case 1, case 2, case 3, absolute value greater than or equal to a number. So see how there's 3 cases here? That will mean x is greater than or equal to the positive number, or x is less than or equal to the negative version of the number. Okay, write all that down. Let me say a few words about it, then we'll do some real life examples, which I think will make more sense out of it. So there's 3 cases that you're going to see in the homework, and you already saw that's going to be on the exam in 3 weeks, right? Because it's on the practice exam, as we saw, number 9 and 10, I think it was, on practice exam part 1. So take a look. There's 3 cases, absolute value equal, less, and greater. In all 3 cases, I'm showing you how to correctly remove the absolute values, right? Everybody seeing that observation? Notice on the left, they have absolute values. On the right, they all have been removed, right? There's no absolute values here. No absolute values here. There's no absolute values there. I'm showing you correct removal. Logically, the right way to remove them. And that's pretty much what we always do in absolute values, is we correctly get them out of there because we don't like them. They cause trouble. We just yank them whenever we see them, but we've got to yank them logically, faithfully, correctly, what's true. So, all right, so everybody got that down? Now I'm going to do some examples, which will hopefully make some sense out of those three cases. But you got to get those exactly. So this is the kind of thing where if you turn one symbol the wrong way, it means something different. And, you know, it's serious. This is where my grading might seem harsh. You know, if you do everything right, but you just have this symbol, well, that means something different. It's a big deal to get those symbols the other way. It's not just a small thing like adding wrong. It's a concept. So make sure you see that, and I want to try to, with the time we have, appeal to you logically that's really true. So let's talk about it. So if you didn't get that down, it'll be on the website later. So let's do case one again. If you have absolute value of, let's say, and it doesn't have to be x. I can make it 3x or whatever. 3x equals 6. So just think with me logically for a minute. If I say, hey guys, I'm thinking of something and the absolute value of it is 6. I'm thinking of some number in my head. Okay, I got a number in my head and the absolute value of it is 6. What does that mean my number could be?
2 or negative 2.
Well, I mean, you're thinking of the x, but yeah, you get the idea. It could be positive or negative, couldn't it? That means that inside 3x, the inside could be 6. Come on, pen. Or the inside, well, this pen is slow. It's slowing me down. Or it could be negative 6, right? That inside, and then, yeah, you're right, we're going to divide by 3, it'll be 2 or negative 2 in the end. Right? That makes sense, doesn't it? If the absolute value of something's coming out 6, then that inside thing could be 6 or negative 6. Either way, the absolute value of it would come out 6, wouldn't it? That's what I was saying when I wrote case 1 a minute ago. If you have absolute value equal, you remove them, right? Look, this is removed. Let me write that word. Come on, pen. We want to write things. Remove. Come on. Boy. I read the reviews that the pen was slow. I agree. It's a little slower than I would like. Anybody knows any tricks to make this pen respond? Am I online or doing something that's causing it to be slow? Let me know. Removed. So the absolute values are removed on that line, aren't they? Again, it's all about correct removal. Everybody seeing that? They start with absolute values, next line, no absolute values. Right? Everybody seeing that? And then, you know, from there it's cake. Once they're off, you know what to do. Just divide by 3, divide by 3. That part's child's play for you. But the removal is the part I really want to make sure you're clear on. So that'd be 2 or negative 2, which is, of course, the truth. From the beginning, x could have been 2 or negative 2, right? And that would have made the thing true. Everybody good on that one, first off? Let's go to case 2. So case 2, which is actually the problem that we had on the screen. What was the problem we had on the screen? In fact, yeah, let me just go back. I'm going to go back. So let's do it. Number 20 here. All right, so absolute value 3x less than 15. So that's an absolute value less than. This is case 2. Less. Absolute value less. And it doesn't matter. I think I wrote less than or equal to, whatever. Same thing. That's just a bracket, parenthesis, right? So absolute value less. Absolute value less. What does that mean? What I told you is in that case, you've got to write the triple statement. The negative 15, the 3x, and the positive 15. Everybody see that? See how that works. Let me go back 2 screens to show you. Yeah, there it is. See this. Let me help you with this. So see how absolute value equals, it's just the positive name. Absolute value less is the triple statement, right? Absolute value greater is the 2 separate with the or. So you've got to get that exact form. It means different things logically on that. This might help, you know, as you memorize things. Notice how this part appears right there, verbatim. And this part appears right there, verbatim. And then there's a negative part also. Everybody see that? All right, so let's go back. So here we are. So we're looking at this. And so once, that's the removal stage, right? I removed the absolute values, didn't I? After that, it's cake. You know how to do it. It's all about correct removal. So now we divide by 3, and we get negative 5, x, positive 5, we're done. They want interval notation, so that would be negative 5, comma, positive 5. Whoops, it's not working very well. And we're done. All right. Is that good? Is that making sense? Okay, let's go on to, you guys got that copy down? I'll move on to case 3. Well, before I do, let me appeal to you. Do you see, does that make sense? There's always the steps you want to memorize, and then the more it can make sense, the easier it'll be to remember and to do right. Does it make sense that if you have the absolute value of something, anything, less than 15 or any number you want, that means that number can be anything from if you did a number line, it could be anything from, let's do equals, from negative 15 up to positive 15. Doesn't it? I'm just giving you the logic behind these steps. You don't have to write this down, but the more I can make this make sense for you, instead of just monkey see, monkey do, imitate the steps. Like, why is that true? Well, because think about it. If I said, hey, the absolute value of something is coming out less than 15, less than or equal to 15, whatever. What does that mean about that number? What numbers could be in there that would make that true? Well, it could be 0 or 1 or 2 all the way up to 15, right? Or could be negative 1, negative 2, all the way down to negative 15, right? Could be anything between negative 15 and positive 15. Because the absolute value of them would come out less than 15, wouldn't it? Negative 15, negative 14, negative 13, negative 12, all those numbers, all 0, 1, 2, 3, up to 15. Absolute value of them would be lower than 15. That makes sense, doesn't it? That's why we do the triple statement, because it's between. The x is the shading. Whatever you say about x, you're saying about the shading. The x, the shading, is between two, for less. Now, not the case for greater. All right. So now we have absolute value of 5x, but this time it's greater. Okay, so how do we do that? What does that mean? Just think with me for a second. Well, let me do the official step. The official step says you need to go 5x greater than 10. You don't make a triple. It's not the triple thing, what's called a compound inequality. I rarely use the official math lingo. It's not a compound inequality. It's not the triple thing. That's for absolute value less. For absolute value greater, it's the two separate with the or. And the first one's identical. It's just without the absolute values now, right? This is removal. I'm on the removal stage. No more absolute values. Yeah. Or, and then you turn the symbol and make it negative, don't you? Turn the symbol and make it negative. Everybody good there? That if you make it through that step, you'll do the rest fine. It's all about that correct first removal step.
So when you turn that symbol, it has to be turned to a negative.
It does, yeah. Let's finish it up, and I'll try to appeal to you logically why that's true. But yes, that is the right step.
I mean, it makes some sense here. I just missed that part.
2, and then this last one, 5. Come on, pin. And then this is x less than negative 2. So there's our answer. Oh, yeah, they want interval notation. Do you guys know what that means on the number line? You don't have to do number line, but it might help. That means parenthesis 2 greater. This is x greater. That's that one. And this one is over here. Here's the x less. It means those two sections. You tracking with me? X greater than 2 means 2 to the right. X less than negative 2 means negative 2 less. So remember, the x is the shading, isn't it? So if we have two x's, we have two shadings. Whereas on the absolute value less, we had 1x. It was a triple statement with 1x in the middle, wasn't it? 1x, one shading. So let me say that again. Did you hear that? Just trying to help you memorize this thing. So, oh, you get a 3x5 card. Did I already say that? You get a 3x5 card in the test. So this is almost the best thing to write down for this first test. Because this is the most real specific technical thing almost that we'll have. Yeah, so you get a 3x5 card you can have with you on the test. Write anything you want on both sides of the 3x5 card for each test. This would be a good thing to write down, those three cases, absolute value equals, less, and greater. So less has less x's. It's not logic, it's just a dumb, easy way to memorize it. Less has less x's, more has more, right? Did you track with that? For the absolute value less, we only had one x in the middle, right? For the absolute value greater, you end up with two separate x statements with an or and two shadings. So absolute value x greater, greater has more, 2x is two shadings. Absolute value less, less has less, 1x, one shading in the middle. So how do you say this in interval notation? What is this over here? Left forever, negative infinity, and right forever, regular infinity. So the answer would be negative infinity, negative 2. It's all parentheses on this one. They want you to put a u in the middle, unite. I really don't care if you skip the u on the test. United to 2 to infinity, like that.
What does it mean the solution is an empty set?
Oh, it means there's no answer. Yeah. So, yeah, so now why? Again, I don't want to just say, here's the steps, monkey see, monkey do. Why? Because, well, logically, think about it. If I say the absolute value is something, let me just give you a number like 2, nice easy number. If I say, hey guys, the absolute value of something, whatever, blah, 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 it could be 10x minus 33 plus 4x, whatever. Absolute value of something is coming out greater than 2. Or let's do greater than or equal to, make it easier. What does that mean logically? I mean, what does that really mean? If I say, hey, I'm thinking of something, I get some number, and the absolute value of it is 2 or more. That's what that's saying, right? I've got some number, make that a number. I got some number, and the absolute value of it, I just want to show you that this is true, this is logical. Got some number, and the absolute value of it comes out 2 or more. What does that mean that number could be? Well, it could be 2 or more, 2, 3, on up you go. Or, what else could it be? Negative 2, negative 3, down to negative 10 million, right? That's true, isn't it? It can be really tiny, negative 2, negative 3, negative 4, because all the absolute values of those will be 2 or more, or really big. So in other words, it's 2 sections on the outsides, isn't it? Going to the negative infinity and the positive infinity. It's not the one in the middle. Everybody see how that's logical? That's why absolute value greater ends up with 2, bigger than the big one, smaller than the small one. 2 outsides, huh? That's reasonable, right? Whereas, come back over here, the absolute value less, if I say I've got a number and the absolute value of it is less than 15 or less than whatever, that means the number's between negative 15 and positive. It's in the middle. So it's 1x in the middle, isn't it? All right, well, so those can be kind of tricky questions on those. How are we doing? The trick is that they're giving you a number that doesn't have an x. See the absolute value negative 4 there? That's just 4. Don't worry about those absolute values. See how they're trying to be tricky? You only have to do all the special stuff about the greater, less, all that, when there's an x involved. We'll do that for the negative 2x on the front. Yeah, we'll have to worry about all that. But they're trying to see if you know what to do. Oh, done. Okay. Are you happy now? All right. So they're trying to see if you know what to do with the negative 4. Yeah, and we just make it a 4. So if they just give you a number, don't sweat it. Just make that a 4. So let me show you about that. Yeah. So that's just 4. It doesn't even have an x. We know what that is, right? The rest, now leave it. Okay, now what do we do? First, exactly right. First, subtract that 4. So first, you guys are right. This is on the test, and a lot of people stumble over it. You might have seen it, notice it was like number 9 or 10 on the price test, where I have a number outside of the absolute value, and a lot of people stumble. They think you could go 6, negative 6 right now. You cannot. That's not true. You can't. You're not ready for removal. You're not ready to yank off the absolute values and go 6, negative 6. No. You've got to first get the absolute values alone. First get rid of the 4, I'll just say. Rid of the 4. So you do that first off. And what do we got? Absolute value of negative 2x less than or equal to 2 over there. This is m4b. We started at 11. All right, so we get to there. Everybody get, now we go to normal mode where we yank off the absolute values, right? Just give them a yank. And you say, okay, now which case is this? Is this going to be like the triple, the compound, or is it going to be the two separate with the or? Is it less or more? It's absolute value less. So it's less x's, in other words. Less shading chunks. 1x, not 2. If it was absolute value greater, then that would be 2x's with the or, right? But if it's absolute value less, it's less. It's the one phrase in the middle. And at first you do the whole, come on, Pan, let's go. Put the whole thing in the middle. And it's trapped between the 2 and then the negative 2. Like that. And then how do we finish? Oh, yeah. How do we finish from there? What do we do? Now, yeah, but notice this was removal. There were absolute values, and then there were not. Everybody notice that? Okay, I say all that because what I've seen over the years is I'll see students like they still have those on like at that point. That's where you'll find me, you might think I'm a hard grader. I'll be like, even if you get the right answer in the end, if I see those kind of steps in the middle, I'll go, no, they're not tracking logically. They're kind of just monkey see, monkey doing. That's not true. This, with the absolute value still on there, would not be true. That's not logically true. And that's what we're really going for. I mean, what is math about? It's about learning to think logically and some of the practical things we can do with that. But a lot of it is developing your logic, right? This is logically true now. So we remove them and write that symbol. Divide by negative 2 on through. Like that. And what? Yeah, I divided by a negative, huh? Yeah, right, guys. So both these symbols need to flip because I did the negative dividing on both sides of both symbols, didn't I? So both symbols need to flip. This is positive 1 now, right? Because 2 negatives make positive. And this is negative 1 because positive over negative is negative, huh? Everybody see that? Now, if it bugs you, it kind of bugs me, having them flipped like that. I would just grab the whole thing and flip it around. I hope I'm not confusing you. There's 2 kinds of flips I'm talking about. On this line, I flipped just the symbols. Nothing else moved. Because that's what you do when you divide by negative, right? As we learned. But now I'm saying take the entire expression and turn the whole thing around because we like to have the smaller. I mean, you don't have to. If you leave this on a test, I'll give you full credit. This is fine and right and true. But it's not the way we normally see it. So if it bugs you, then and of course you kind of need to, it'd probably be easier for you to put the smaller number first. And just grab the whole thing and turn it around. So it'll be negative 1, x, 1, like that. That's the same truth. Do you see that? The whole thing just turned around, saying the same truth. So what's the interval notation answer? Negative 1 to positive 1. Brackets, because of the bars, right? We good with that? We good? Questions on that one? Whoops, that's not what I meant to do. See how they're saying absolute value there? So and the x differs from 6 by less than 3/7. That means absolute value of x minus 6. Difference means subtraction, right? Is less than 3/7. That's what they're wanting you to do there. They're saying make it absolute value, make it a difference. Absolute value x minus 6 less than 3/7.
They just want you to write the equation.
No, then the rest is like what we did. Yeah, then go on and solve it and finish it up from there. I just wanted to show you how to set up the words. Is that good? Questions on that? That makes sense? All right, so we finished that up. So this section, Appendix 9, that we just finished, we did virtually all of it. That'll be due Thursday at the start of class at 11 a.m. on mathexcel.com. And if you have questions on something, feel free to hang out. Otherwise, I will see you Thursday. Have a good day.